All right. Last week we introduced you to matrices. We talked about adding, subtracting matrices. We talked about scalar multiplication. This week we're moving into matrix multiplication. Today's lesson we will multiply matrices that have dimensions 2 by 2. And then tomorrow we will move into matrix multiplication for all sizes of matrices. For this first review part of your notes, I'm not going to go through the whole thing. You have the solutions in your completed notes in your PDF in your Google Classroom, but I will just briefly talk about a few things from last week. We have these two matrices, N and Y, and in part A, it's telling us to find 2 times capital Y. Remember, when you see the capital letter, it's the name of the matrix. So it means 2 times matrix Y. So basically what that means is you take matrix Y, you're going to multiply it by 2, which means you're distributing that 2 to every entry in the matrix and you're multiplying. So that would give you this answer matrix. 6, 12, negative 18, 12, negative 4, 0, negative 20, 2, and 8. I won't work B and C for you, but pause the video right now and try them out, and then go check your work on the filled out notes that you have. All right, so let's move on to, so this was again called scalar multiplication. You take one matrix, you multiply it by a constant. But today we're going to take one matrix and multiply it by another matrix. Even though the actual problems we're going to do today are all 2 by 2s, this general example here is not, but it's a good illustration of a bunch of things we need to talk about before we do the practice problems. So if you look here, there are 2 matrices. Think real quickly, what are the dimensions on this first matrix? Meaning, what are the rows and what are the number of columns? The rows are 2. Remember, rows are horizontal. So we have 2 rows by how many columns? Remember, columns are vertical, like columns on a building. 3, okay? Now take a moment and write down underneath the second matrix what its dimensions are. Hopefully you came up with 3 rows. That's how many things are going horizontal. And 2 columns. Now look at those dimensions for just a second. I want you to notice something important. These numbers right here are the same. Those 2 things have to be the same in order to do matrix multiplication. So that is this sentence right here. Matrix multiplication is only possible when the number of columns of the first matrix equals the number of rows of the second. Okay? If you ever are setting up your multiplication and that's not true, your answer would be not possible or not applicable or something like that. But I want to point out here, it's very important that you write those dimensions down in the order that you're multiplying. In regular numbers, the order doesn't matter when you multiply. That's called the commutative property. So that would mean that 9 times 2 would give you the same answer as 2 times 9. The order doesn't matter. This is not true for matrices. Matrix multiplication is not commutative. So keep that in mind when you're doing this, when you're setting up your dimensions and comparing them. And then the next thing I want you to notice is this. The result from matrix multiplication will have this size. The number of rows of the first matrix by the number of columns of the second. And when I say the result from matrix multiplication, I'm talking about your answer matrix, where you put your final results. And that will come from these two numbers right here. So I'm going to read that again, and you look at those green numbers I just highlighted. The result from the matrix multiplication will have this size, the number of rows of the first matrix. So whatever the rows in the first matrix are, that will be how many rows your answer matrix has. By the way, this is our answer matrix over here. There's 1, 2 rows. And then this second part of that statement, the number of columns comes from the second matrix. So that's here. The second matrix had 2 columns, so your answer matrix is going to have 2 columns. And if you feel like that's something you're going to forget, well, you're probably right. But I'm going to repeat it often enough with the practice problems that you should get the hang of it. And if you need to come back to this video, this right here, this is the money part that you want to remember. That will help you figure out 2 pieces of information. The purple highlighted stuff tells you if you can even do the multiplication in the first place, if those are the same or not. The green highlighted information tells you the dimensions for your answer matrix. It's going to be a 2 by 2. Okay, so that's fine. But how do you get the answers that go into your answer matrix? So that's what we're going to talk about next. And this is the actual process of multiplying matrices. So I'm going to erase all that stuff that I highlighted here so that we can see things a little more clearly. All right. So we just talked about how our answer matrix was a 2 by 2. The rows of the first one by the column of the second. And so here's the basic idea behind multiplication. You're going to take the rows of the first matrix and multiply by the columns of the second one. But what does that even mean to multiply those? There's 3 numbers in the first row and 3 numbers in the first column. How are you going to get one answer from 3 different things in each one? Well, here's what you do. You take the first entry in this row, multiply it by the first entry in this column, A times G. But then you just hold that information. That's not your actual answer. It's just going to get us to our final answer, okay? And you'll see that A times G right here. The next thing you do is you just move to the second entry. The second entry of the first row and the second entry of the first column. And you multiply those, B times I, and you'll see that right here. And the last thing you do is move to the third entry. The third entry in the first row here in that first matrix, and the third entry in the column there, and you multiply those, C times K. So now you have these 3 numbers, and you add them all together, and that's going to give you one number. And that number goes, remember I told you that our answer matrix for this was going to be a 2 by 2? So there's open spaces for all my 2 by 2. I got 2 rows, 2 columns. Whatever you get here, when you add up those actual numbers, when we're working with actual numbers, goes in the first row, first column spot. And that's how you know where your number is going to go. Whichever rows and columns you happen to be multiplying, that final answer goes in that row column spot in your answer matrix. So like, and there's 4 different combinations you can do. So we just did row 1, column 1. We could have done row 2, column 2. Where would that answer go? Way over here in my answer matrix. It would go in the row 2, column 2 spot right here. That's row 2, column 2, where they intersect. what would we have multiplied to get that? The DH, which is the first entries in that row in that column. EJ is the second entries in each one. And FL is the third entries. But there's other combinations we could do. You have to do every combination until there's no more. So that number would have gone here. But notice I'm still missing 2 entries. Where do those missing numbers come from? Well, they would come from here. They would come from row 1, column 2. That would be this math right here. AH, BJ, CL, and that number would go here. And then the last combination would be row 2, column 1. The D times the G, the E times the I, the F times the K, all added up, and that would go here. Row 2, column 1. Right, and that's the basic idea about matrix multiplication. So let's look at some actual with real numbers. Now, doing all 2 by 2s. So I'm going to go through that dimension comparison thing that I told you about. Even though today, since they're all the same dimension, they're all going to work. But I just want you to see it modeled again. So for number 1 here, it's asking us to find matrix J times matrix A. Remember that the order matters. You cannot switch these and get the same answer. So J has to come first. So that's this, -2, 3, 1, and 4. And A is 4, 6, 3, 1. Let's first talk about whether this is even possible. So J has is a 2 by 2, and A is a 2 by 2. So I told you to look first here. Do the columns of the first matrix match the row of the second? The answer is yes. Therefore, you can multiply. If they didn't match, we would not be able to do anything. We would just say you can't do it. But everything's going to match today. Now, the dimensions of your answer matrix come from the other 2 numbers. The row of the first matrix and the column number of the second. So I like to do this. I like to go ahead and set up my answer matrix and give myself spaces to hold place for where the numbers are going to go. For today's matrices, they're all going to be 2 by 2, so this might seem like a little bit of overkill, but when we get into the next lesson where the dimensions are different and some are larger than others, this will be very, very helpful so you don't get lost in the middle of your math about where your answers are supposed to go. All right, so here's our first dot product, which is where we do a row by column and figure out what our answer is, okay? So I'm just going to start with row 1, column 1. And where is that answer going to go? When I finally get it, it's going to go in my row 1, column 1 spot on my matrix over there. So the first entry in the row is -2. The first entry in this column is 4. Okay, so I'm going to multiply those together. The second entry in the row is 1. The second entry in this column is 6. I'm going to multiply those together, and then I'm going to add them. So this gives me -8 plus 6, which is -2. That is what goes right here. Now I'm going to move on and do row 1, times column 2. Where's that answer going to go? In my answer matrix, it's going to go in the row 1, column 2 spot right here. So row 1, entry 1 is -2. Column 1, entry 1 is 3. That's their corresponding entries. Now I want to do the second entry in row 1 times the second entry in column 2. And then what am I going to do with those things? Add them, not even them. So this is -6 plus 1, which is -5. And that goes here. I want you to pause the video and do row 2, column 1, dot product, and row 2, column 2, dot product. Okay, hopefully you gave yourself some time to try that. Remember, it's okay if you got it wrong or you're not following along really well. As long as you're trying and trying again, eventually you'll get the process down. It does take practice, but once it clicks for you, you'll be able to do any of these problems. It will be no big deal. Let's do, okay, so now we are going to do row 2 times column 1. That did not work very well, did it? Row 2, column 1, and that's going to give me row 2, column 1 answer right here. The first entries are 3 and 4. Those get multiplied. The second entries are 4 and 6. And we're going to add those. So that's 12 plus 24, and that is 36. And now we're going to do row 2, column 2. The first entries are 3 and 3. The second entries are 4 and 1. You're multiplying those things and then adding them together. Okay, so that's your final answer. -2, -5, 36, and 13. Take a moment and try number 5, SA. All right, so let's talk about what you should have gotten when you did S times A. You should have had 22, 27, -36, and -6. Some of you might find that you got 2 of the answers right and 2 of the answers wrong, so you're not sure exactly where you messed up. So let's look at how this goes. So S is 10, 0, -3, -6 times A, which is 4, 3, 6, 1. Remember, the order matters, so it has to be S written on the left and A written on the right. Just to model this for you again, for the repetition, 2 by 2, you're comparing if these 2 numbers are the same, and they are, so therefore we can go forward with our multiplication. And then the dimensions for our answer are these numbers on the outside. So I'm going to go ahead and set up my answer matrix as a 2 by 2. My answers are going to go in these spots. So let's talk about which ones we're doing first. Look, find your row 1. It's 10 and -3, right? And then find column 1 in the second matrix. It's 4 and 6. What was the first entry in that first row? It was 10. And what was the first entry in the first column? It was 4. Those get multiplied. Now, what's the second entry in the first row? negative 3. And what is the second entry in the first column? It's 6. And those are getting multiplied. So put your fingers on the 10 and the 4. That's the first spot. Multiply them. Now put your fingers on negative 3 and 6. That's the second entries. You multiply them. But what do you do with those two things after multiplying? You add them. So this is 40 minus 18, which is 22. So then let's say you have the answer, but you're like, where does that go? Well, you just took the dot product of row 1, column 1. So that's where your answer goes. It goes in row 1, column 1. Now let's do row 1, column 2. Put your fingers on the first entry in each one. So that's the 10 and the 3. Those get multiplied. Now put your fingers on the second entries. The second entry in row 1, the second entry in column 2. That's negative 3 and 1. You're going to add those things together. That's 30 minus 3 is 27. Now where does that go? Well, that's the dot product for row 1, column 2. So find the spot row 1, column 2 in your answer matrix and put your number there. All right, so we have 2 more things to find. So we're moving to the second row now. So I'm going to do the second row in the first matrix and the first column in the second matrix. So what are their first entries for each of those things? 0 and 4. So we multiply them. What is the second entry for each of those things? The second entry for row 2 is negative 6. The second entry for column 1 is positive 6. We're going to multiply those. And then we're going to add those things. So 0 and negative 36 is negative 36. That is row 2, column 1. So my answer goes in row 2, column 1. And then let's do the last spot. Row 2, column 2. So the first entry in row 2 is 0. And the first entry in column 2 is 3. The second entry in row 2 is negative 6 times the second entry in column 2, which is 1. And we need to add those together. 0 plus negative 6 is negative 6. Okay, so this one should have been in red. So I'm not going to work all the rest of the examples for you. I do, though, just want to talk about one more problem with you. So if you go down your notes sheet and look at 7 and 8. And what's different about the way that's set up than the other ones? Do you notice? They say squared, right? But squared is just repeated multiplication. So let's look at number 8. S squared means matrix S times itself, matrix S. And so that looks like this. S, which is 10, 0, negative 3, negative 6, times itself. And yes, I already know that we already know that a 2x2 is manageable. Like it's fine. You can do that. But I'm still going to do this thing with the dimensions because repetition is good for you. Repetition is good for you. Repetition is good for you. So those two things are the same. That means yes, we can perform this multiplication. And my answer is going to have dimensions of this 2 rows by 2 columns. So my answer has 2 rows by 2 columns. So I'm going to set up my answer matrix like this. And that's where my answers are going to go. I want you to pause the video, take a moment and work this problem, and then come back and check out my work and compare it to yours. All right, so here is my work. I've color-coded it, which should be helpful to all of you, except maybe Sergio. Sergio, put your glasses on at this time. The first row, first column answers in red, and then you can see, and I tried to make my arrows color-coded as well. So where the red arrows are pointing, that's the red work. Where the green arrows are pointing, that's the green work. It's very easy to get lost in your math, so I recommend if you're the kind of person who likes to work with colors and you have your highlighters and your colored pencils, when you're doing each new answer or dot product, like my red work right here, go ahead and use a different color highlighter to highlight your row and your column, or use a different color pencil, or put your fingers down on the paper to hold your place. Find some method that works for you. And by the way, you're not going to find that method just by watching me do the video. You're going to have to practice the problems repeatedly till it clicks, till it becomes second nature, until you find a method that works for you. Okay? So I'm not working the rest of these examples. They're in your Google Classroom. Practice them and then do your practice problem worksheet. Take a picture and upload to your assignment.